Okay, so welcome, and now we're going to do another example where we have now a double angle here equal to cosine theta. So we have cosine 2 theta equal to cosine theta, and they don't give us a range. So this is going to be for an infinite number of solutions for this one. So the first thing I'm going to do is I don't want to have the 2 theta there. And since I have a cosine theta here, I'd like to get this where I have cosine theta over on this side. So that only leaves me one of the identities of the 3 that I can use for cosine 2 theta. And it's the one that just has cosine squared theta in it. And so what I'm going to do is replace this with what it's equal to, which is going to be 2 cosine squared theta minus 1 is equal to cosine theta. Okay, so now the trigonometric function now looks like this, which now I can use it and I can subtract this over here and make it into a quadratic form. So let's do that. So I get 2 cosine squared theta minus cosine theta minus 1 equals 0. And so now I can use the method of decomposition along with the AC method, right? And so I'm going to take 2 times negative 1, so that gives me negative 2. Since this is negative, I know I'm going to have opposite signs for my 2 factors, and the larger factor is negative. Okay? So, guess what? It's going to be negative 2 and 1. Okay? So negative 2 times 1 gives me negative 2, and negative 2 plus 1 gives me a negative 1. And so that's what I'm going to do to decompose the middle term. So 2 cosine squared theta minus 2 cosine theta plus cosine theta minus 1 equals 0. And now I'm going to group, right? So now I'm going to factor by grouping here. And so now I'm going to factor out of this one, it's going to be 2 cosine theta. So I'm going to factor out 2 cosine theta. And that's going to leave over cosine theta minus 1. And then of course I have cosine theta minus 1 here. So I'm going to put in the imaginary 1 here. Times cosine theta minus 1 equals 0. And now I'm going to factor out the common factor here. And that's going to give me cosine theta minus 1. And times what's left over, it's going to be 2 cosine theta plus 1 equals 0. And of course, this tells me that using the zero product principle, cosine theta minus 1 is equal to 0, or 2 cosine theta plus 1 is equal to 0, which tells me that cosine theta is equal to 1, or cosine theta is equal to negative 1/2. Okay, now I can use the unit circle to find what these are. So using that, theta, okay, and I'm just going to do from 0 to 2 pi because I just want to find for one period, okay? So from 0 to 2 pi, I know that cosine is 1 when theta is equal to 0, okay? And cosine is equal to negative 1/2. And again, cosine is negative in the second and third quadrant. Okay? So it's going to be equal to, again, it's negative 1/2, which means this is going to be cosine of a 60-degree angle. Again, use your unit circle and your reference triangle to figure it out. But this is going to be a 60-degree angle, and so so what are the 2 quadrants? It's going to be to negative in the third and fourth. No, it's going to be negative in the second and third quadrant. Okay, so in the second quadrant, since I'm dealing with a 60-degree angle, that's going to be what? So 60-degree reference angle. 60-degree reference angle, which is pi over 3, is going to be at 2 pi over 3. Okay? Or in the third quadrant, it's going to be 4 pi over 3. Okay? And so those are going to be the angles. Okay? Now, let's see here. Yeah. So now, okay, now that we got the 3, now we just got to write them for all possible, because again, there's an infinite number of answers. So for 0, right? For 0, this is going to be equal to theta is, well, all multiples of 2 pi, right? Remember, it's a period 2 pi, so that means it's going to be equal to 2 pi times k. Okay, so that's going to be 1. Right? And if you want to write it with 0, well, actually, it'd be better to write it with 0. So it'd be 0 plus or minus 2 pi times k. And the other one is going to be, or theta is equal to what? 2 pi over 3 plus or minus 2 pi times k. Or the third one is going to be theta is equal to 4 pi over 3 plus or minus 2 pi times k. And of course, for all of these, k is an integer. Okay? And so the solution set would be contains all of these. And that would be an infinite number of solutions. Okay? Have a great day.